Hello friends, my name is Prashant Katiyar. I am the faculty of the Life Science Academy. This is the premier institute for GATE and CSIR NET exam preparation. So today's video we discuss about the enzyme known as oxidase. Okay, oxidase. Everyone knows about oxidase. It is an enzyme which catalyzes the reaction of oxidation. For example, if fatty acid, saturated fatty acid, this is saturated fatty acid, is oxidized to generate unsaturated fatty acid, and this kind of reaction is catalyzed by oxidase enzyme, which contributes oxygen and transfer this electron to the oxygen molecule. This is molecular oxygen, where electron is transferred to the electron by this enzyme and introduce the double bond in saturated fatty acids. But here we see that this oxygen molecule is not come into the product side. It is not involved in this intact form. So many example of this kind of reaction is there. This is the one of the example when the fatty acid is undergo for oxidation. When this fatty acid is oxidized, then this kind of reaction is occur. Okay. So in this category, the other name of this enzyme is known as oxygenase. And if this under this category, this is further categorized into two forms. One is monoxygenase and another one is dioxygenase. Okay, this is called mixed function oxidase, or you can say mixed function oxygenase enzyme. So what is the function of these two enzymes which belongs to this category, oxygenase or oxidase? It is also called oxygenase. So the basic difference between these two enzymes is if monooxygenase is operating this kind of reaction where saturated fatty inside the saturated fatty acids, one double bond or two double bond is introduced by the help of this oxidation reaction, then this mixed function oxidase enzyme is introduced. But here is that if we look closely this reaction, then the molecular oxygen is that is the molecule. This is further, if atom is formed by molecule, then it have two oxygen atoms. So this oxygen atom is one oxygen atom. Whenever the monooxygenase is operating, then one is their substrate, that is main substrate. For example, AH2 is the main substrate, and another one is BH2 is CoS substrate. Okay, so when this both oxygen atom is contributed by this enzyme monooxygenase, then how can it react? How can these oxygen atoms react to these substrate molecules, substrate reactants? Okay, so from main substrate, one oxygen atom is uh, reacting and generate the hydroxylated product, and one oxygen is reacted with this H2, then it generate a H2O, and this co-substrate is released as free form. Suppose this B is released as free form. This is the free form. So what is the example of this monooxygenase? Generally, if we take an example of aromatic amino acid, that is phenylalanine. When phenylalanine is oxidized in the presence of this monooxygenase, then phenylalanine is act as a main substrate, and the co-substrate is tetrahydrobiopterin. What is tetrahydrobiopterin? This is the co-substrate and this is the main substrate. So as this, similarly, this if we compare this reaction to this reaction, then the product is generated is hydroxylated product. So this phenyl ring containing one phenyl ring, it has phenylalanine having phenyl ring where H is attached, and this attached hydrogen ion is converted into hydroxylated product. Remaining structure is same, is there is central carbon atom where H ion, NH3 group and CH2 group is attached. So remaining structure is same. This is the structure, but difference is that this attached hydrogen is converted into hydroxylated product, and this product is called tyrosine plus H2O, and tetrahydrobiopterin is released as free form, as B is released in this way. Okay. So conclusion is that this oxygen atom is out of two oxygen atom, one oxygen atom is reacting with this main substrate and generated hydroxylated. Other one is released as H2O molecule. Okay. So this is the monooxygenase function. And what about this enzyme dioxygenase? How can it is work? So in this there is no, the difference is there is a main substrate but there is no co-substrate. So both the oxygen atom is contributed into same main substrate and released as both hydroxylated or carboxylated product. So both oxygen atom is contributed in the main substrate in case of dioxygenase. So what about this enzyme dioxygenase? This dioxygenase, actually the best example of this dioxygenase is oxidation of tryptophan. This is one of the aromatic amino acid, and this tryptophan it has an open pentameric structure which is oxidized into in the presence of oxygen of dioxygenase. If you look this enzyme closely, its full name is tryptophan 2,3-dioxygenase, where both the oxygen atom is contributed in this main substrate and it generate a compound known as N-formyl kin-uridine. This is the product of this. When this pentameric ring is converted into carboxylated product, this is the carboxylated product, and it's this product is known as N-formyl kin-urine. Okay, so here the basic difference is this: both the oxygen atom is contributed in main substrate. There is no co-substrate, but there is a presence of co-substrate and main substrate. One oxygen atom is contributed in main substrate and another one is contributed in this H2 is released, and this co-substrate is free as in this form. This is the example of this, and this is the example of this dioxygenase. So for more details about this topic, you can contact us, the Life Science Academy. Okay, welcome.